In this video, we're going to be testing the claim about a standard deviation using the critical region method. To do this, we're going to need a test statistic formula for standard deviation, and that is chi squared equals n minus 1 times s squared all over sigma squared. And what each part means is over here. Don't forget, we do need to know what the degrees of freedom are for questions like this. So for this example, a simple random sample of 25 filtered cigarettes is obtained and the tar content of each cigarette is measured. The sample has a standard deviation of 3.7 milligrams, and we're going to use a 0.05 significance level to test the claim that the tar content of filtered cigarettes has a standard deviation different from 3.2 milligrams, which is the standard deviation for unfiltered cigarettes. So the first thing we're going to do is we're going to write out our hypothesis test. So our null hypothesis, and since we're dealing with standard deviation, we use sigma equals, and we go to what the claim is, and the claim says we're going to test the claim. Tar content of filtered cigarettes has a standard deviation different from 3.2. So sigma equals 3.2, and in the alternative, sigma, since it's different, is not equal to 3.2. We also know that our alpha value, our significance level, here, 0.05, so alpha is 0.05. We have the degrees of freedom coming from n minus 1, which is n here, 25, so 24. And we also have a sample standard deviation S of 3.7 coming from here. So there's our hypothesis test written out with all the information we have from this. So what we're going to need is we need to find the critical value. And since this is a two-tailed test because it is not equal to in the alternative, we're going to have two critical values. And the way we find it, by doing this. We take our alpha value, 0.05, and we divide it by 2 because it is a two-tailed test. And we're going to get 0.025. But since it's two-tailed, we got to find the other side as well. So we're going to do 1 minus 0.025, and we're going to get 0.975. And so from these two, we're going to find our critical values. And the way we do that is we use a chi-squared table. So we're going to find the chi-squared of 0.025 and 9.75 with our degrees of freedom being 24. So in our chi-squared distribution table here, and this is the kind of chart we're going to draw in a second. It won't be 100% accurate, but it'll be something similar to this. We're going to use that and find the critical values down here. So we know our degrees of freedom are 24, so 24 is right here. And we also have 0.025, so 0.025 right here for chi-squared. And so we're going to go down until we get to where they match up, which will be at 39.364. And then we also have 0.975, which is right here. And so we go where that matches up, which is down here at 12.401. So these two down here are our critical values. So we're going to have 39.364 and 12.401 as our critical values. Now we still have to find our test statistic, and we find that by this formula right here. So we're just going to plug in what we know for n, s, and sigma, and that'll give us our t-stat, our test statistic. So our t-stat is going to come from chi squared equals n minus 1, so we can just say that's 24, times s, so 3.7 squared, over sigma squared, 3.2 squared. And just do the arithmetic, just run that through, and we're going to get 32.086 to 3 decimal places. So we know what we're going to be testing. Now we need to draw our picture and put our critical values in to see where our t-stat falls. So draw on the picture, not 100% accurate, but that's okay. I'm just trying to give myself an idea. So we know that 0 is here, and the first one we have for critical values is 12.401, which I'll say is here. So we have this area shaded over here. And the next one is 39.364, which I will say is here. And we're shading everything over here. And now we're going to take our t-stat, 32.086, and we'll say that this is here, more or less. Well, I can see it's definitely not in the shaded area. It's not in the rejection region. So I will say that this is not in rejection region. And since it is not, I can say that I will fail to reject the null. Now, since I know I'm failing to reject, I still need to write out my conclusion based on this in about a sentence or so. So, writing out my conclusion, I can say, since we failed to reject, that there is insufficient evidence to support claim that the tar content of filtered cigarettes has a standard deviation different from 3.2 milligrams. And just zoom out to see everything in one nice screen, including the test statistic formula. So that's how you would go about doing this using the critical values region. Again, if you have a two-tailed test, you need to divide your alpha value by 2 and then do 1 minus to get the other part as well.